Okay, Ray Gallucci up here again, and I'm going to follow up what Duncan discussed this morning, looking at some of the, not all of the aspects of his ether concept of gravity, but the ones with which I was able to do some mathematical analysis to see whether it passes the test of plausibility. Just before I start, just want to mention my wife found this Einstein hat at the Smithsonian, but I had to add the tongue to it, else I would not have worn it to this conference.
I thought it was fun.
Okay, Duncan has proposed an ether explanation for gravity, publishing several papers over the current decade. You can find them on his website, which have evolved into his ether concept of gravity. His theory, if you remember from this morning, inflowing ether into the cosmic bodies produces an accelerating ram force, manifesting as the attractive, in quotes, gravitational force without the need to postulate action at a distance. What I'm going to do is examine three key aspects of his model, which lend themselves to modeling in the form of mathematical constructs as an investigation into the plausibility of this theory solely from a mathematical perspective. In his 2017 article that was at the 2000...
Yeah, just say okay there.
That was presented in Vancouver at our third meeting, he proposed gravity as a pushing, not pulling or attractive force. It has the net effect of attraction, but it's actually pushing. The simple analogy made to a vacuum cleaner, which by creating lower air pressure inside causes air from the outside at the higher pressure to push itself inward toward the artificially lowered pressure region. Rather than sucking in air, a vacuum cleaner allows the air to push itself inward. The inflow is caused, and this is quotes, the inflow is caused by the pressure of the ether in cosmic bodies being lower than the pressure of ether in space, due to the emission of ether from the cosmic bodies. And remember from this morning, he showed inflow and outflow. The resulting pressure differential causes ether in space to flow toward the partial vacuum. Pressure in cosmic bodies is also lowered by the acceleration of inflowing ether from space to the relatively narrow targets of the cosmic bodies. As he mentioned, it's an application of Bernoulli's principle pursuant to which the pressure of a fluid that is flowing in a narrowing channel reduces as the speed of the fluid accelerates. Continuing with his concept of gravity, with all this ether flowing into a cosmic body, Shaw must address whether there is an outflow to maintain equilibrium and prevent runaway heating of the body, and he did discuss this morning. Again, quoting his work, outflow is essential because 1, it replenishes the supply of ether in space required for continuous inflow. 2, it provides a mechanism to dissipate into space the heat that's transferred to the cosmic bodies by the ram force of the inflowing ether. Heat generated by this inflowing force causes inflowing condensed ether to vaporize or evaporate into a gaseous state and flow back into space by way of diffusion and convection, where it condenses into droplets of liquid ether. And remember his analogy, if you drops of water on a hot plate, they basically dissociate and go back off. They gradually come into contact with other ether cells, and with droplets of condensed ether, the supply of condensed ether in space is thereby replenished. This is a similar version to what he drew this morning. It doesn't show the ether flowing out. This was taken from the 2017 paper. It shows the ether flowing in to the, here we have the sun and a planet. But if you remember from this morning, you would also have these arrows that were going outward. Three concepts lend themselves to mathematical modeling within Shaw's theory, at least to the extent I was able to do it. First, the accelerating rate of radial inflow of ether as it approaches a cosmic body. Assumed spherical for convenience. Second, creation of a pressure differential between inflowing and outflowing ether at the surface of the cosmic body, such that the inflow pressure is greater and ends up representing an attractive gravity. Although it's not truly attractive, it manifests as if it was. Third, dependence of inflow versus outflow pressure differential on the mass of the cosmic body, such that two bodies of equal size and shape experience different gravities depending upon their masses or densities. Because if you had Venus and Earth, for example, which are approximately the same size, and pretend that Earth's a little denser than Venus, a little bit heavy, not that much. If all the ether was able to react to was the geometry, Earth and Venus would have the same gravity. But they don't, because Earth is slightly denser and more massive. So there has to be a way for the ether to know that the same size bodies, one is denser than the other. And that's the third aspect I'll look into. For the first aspect, ether inflow. Inflow of ether is dominated by the most massive sun. Again, remember the drawing, it had the big arrows for the sun, the smaller ones for the Earth. That overwhelms that of any planet except in the planet's immediate vicinity. Let's look at 3 dimensions, a spherical sun and planets. The rate of ether inflowing from an infinitesimal shell of radius d, which is distant from planet center to sun center, the distance between the planet center and the sun center, and it has a thickness of delta d over a time increment of delta t, and this is the rate of inflow, 4 pi d squared, delta t over delta t, which is 4 pi d squared. The velocity is delta d, delta over time, delta t, is the radial inflow velocity of the ether at planetary distance d. Defining the inflow rate, the velocity at the sun surface is 1, so I don't have to get funny numbers, do everything relative to 1. And the inflow rates at the planet and the sun, since ether does not build within the solar system, you end up finding that 4 pi r squared times the velocity at the sun 1 equals 4 pi d squared v, again, velocity 1, where it leads to v equals r over d squared, in parentheses, where r is the rate, capital R is the radius of the sun. Since the radius of the sun is much less than the distance between the sun and the planets, d, the velocity of inflowing ether at the planet is much less than at the sun, where it's run, decreasing as one proceeds outward from the sun. And I think that was discussed pretty thoroughly this morning, once again. Gravity results from momentum of the sun's inflowing ether, which is imparted on the planet and is proportional to the ether mass, in quotes, impinging on the cross-sectional area perpendicular to the radial inward flow towards the sun. So we have a planet with radius small r. The impinging mass is proportional to pi r squared. That corresponds to the gravitational push inward at a distance d from the sun, which is proportional to vr squared, which is small r times capital R, the 2 different radii, over the distance, whole thing in parentheses squared, dropping any constant terms so I can work only with ratios. No gravitational constants and stuff like that. The impact effect differs significantly from a solid surface, such as Earth's, to a gaseous one, such as Jupiter's. So we do have to take into account the nature of the impact, the body on which the ether is impinging. Earth, the 4 inner planets are solid bodies. The 4 outer planets, if you push Pluto aside, are gas giants and have a much softer surface, in effect. To compensate for this and for me to do my calculations, I made equivalents of the 4 gas giants as solid planets. So basically I took the mass of each of the 4 outer planets and converted them into solid planets by shrinking them down a lot as if they're a bunch of solid planets on the outside. And it's a fairly simple analogy here. I just assumed that each of them would have a density which is equal to the average of those for the 4 inner planets, which is roughly 5 trillion kilograms per cubic kilometer, and calculate the equivalent radii based on the actual density, rho and r are the planet's actual density and radius, so I'm coming up with the equivalent radius based on the average density for the inner planets. And you can see that this calculation there, we got a bunch here, the sun, Earth, the inner planets out through Mars. And then for the outer planets, these are the equivalent radii for the outer planets, not their actual radii. I retained Pluto. These are the actual densities for the inner planets. This is the average for the inner planets, which I use for my equivalents. And that's the actual value for Pluto. These are the distances from the sun. And this would be the ether velocity from the calculation. So then I calculated the force relative to the sun's gravitational force being equal to 1. And I did it for both the ether aspect from Shaw's model and from basic Newtonian gravitation. You can see that the ratio in both cases are 1. And so scaling to the sun's gravitational forces on Earth being equal to unity, the ratios for each plane of the ether versus the Newton gravitational forces, shown here, here's the figure, agree quite well, especially with respect to the trend, except for a most roughly an order of magnitude difference for the gas giants and Pluto. So you can see the trend here. This is Newton in red, and the ether model from Shaw in blue. And considering these types of approximations I'm making here, especially for the outer planets, that's fairly good agreement, I would think. Okay, that was, so certainly I found the first part of the aspect, which is the ether inflow model, at least to be plausible, consistent with the observed gravitation from Newton's model, which we would expect it to be. Next, I looked at the pressure differential aspect. Here we view the inflowing condensed ether capsule as I chose a tetrahedral package of 4 ether particles, each a sphere of unit radius flowing into a sphere. So I have my 4 particles here in gray, in the form of a tetrahedra. And then what I did is, as the ether capsule flows into a large spherical body, it displaces 4 individual ether particles in a straight line. So basically, to do the calculation, I take my tetrahedra, I make an equivalent sphere out of that, and then I assume that although the ether comes in a capsule, a compact capsule of the tetrahedron, as Duncan explained, when the water hits the table or the hot plate, it dissociates into its constituents. So the 4 come in as a tetrahedral compact package, but the 4 go out linearly, like a cylinder. This is analogous to Shaw's concept of the ram force of inflow causing the inflowing capsule to vaporize or evaporate into its constituent particles. So the equivalent spherical volume of a sphere, again using radii 1 for each of my little spheres, 16.76, corresponds to a sphere of equivalent radius. It turns out to be about 1.6 relative to the unit particle radius. So my equivalent sphere here in red has a radius of 1.6. Assume it's a cylindrical volume for the 4 expelled ether particles. So they're coming out in a straight line, and the equivalent geometric figure is a cylinder. It has an equivalent length of 5.33 proceeding outward in a straight line. The average distance that it's moving is half the length, 2.667. So basically I have ether coming in with an equivalent radius of 1.587, going out with an equivalent radius of 2.667. So what is that? How does that lead to pressure differential? Because the inflowing ether is in the form of a tetrahedral capsule with that equivalent spherical radius of 1.6, its depth of penetration is going to be less than the equivalent average distance traveled by the expelled individual ether particles, 2.7. Radially, this corresponds to particles expelled at about 1.7 times the speed of the inflowing capsule. They go out faster than they come in. And as Duncan mentioned, this is related to Bernoulli's principle. So ignoring gravity at this point, a positive pressure differential results between the inflowing and expelling ether. And this is just a simplified version of Bernoulli's equation without the gravitational MGH type term in here. And it ends up saying that the difference between the inflowing and outflowing pressure is going to be equal to density, half the density times the difference of the squares of the velocity out and the velocity in. And since it's going out faster, proportional to 2.7, and it's coming in proportional to 1.6, we have a positive pressure. The pressure going in is less than the pressure going out. It's greater than the pressure going out. So without knowing the ether's density or its inflow or outflow radial speed, I can still make some rough estimates of the pressure differential requiring some subjective assumptions. So I took this off of the internet, Wikipedia, for the interstellar medium. In all phases of the interstellar medium, very tenuous. In cool, dense regions, matter is primarily in molecular form, reaches number densities of 1 million molecules per cubic centimeter. In hot, diffuse regions, the matter is ionized. The density, they say, could be as low as 10⁻⁴ ions per cubic centimeter. we got a range of 10 orders of magnitude. So usually when you're dealing with tremendous differences in orders of magnitude, when you're going to use a midpoint, you use the geometric mean. So the geometric mean of this range would be 10 per cubic centimeter. I assume this consists of individual hydrogen atoms, which are separated, the protons are separated, and electrons, and in equal numbers if they're ionized. So the corresponding density in terms of kilograms per meter cubed would be 1.67 times 10 to the minus 20. So that's the density of the interstellar medium I use for my calcs. Again, in an earlier paper that Duncan did in Physics Essays in 2013, he assumes, quoting, a spacecraft returning from the moon are being carried by ether toward the Earth. The speeds of the spacecraft en route should be essentially the same as the velocities of the inflowing ether. For example, the velocity of the ether at a point where the vehicles reach the Earth's atmosphere must be about 11 kilometers per second when they start to encounter the braking effect of the atmosphere. And just to get a little perspective on that, that's more than 10 times higher than the maximum terminal velocity ever reported by a skydiver, which turns out to be about 0.4 kilometers per second. Somebody jumped from 130,000 feet at one point in time. So I'm going to use Shaw's estimate of 11 kilometers per second for the speed of ether flowing into the Earth as it approaches its surface. And that's weird. Where did it go? It says there's 4 more slides.
Top of the top,
Let's see. It didn't get copied. Let's see. There we go. Okay. I don't know. Somehow that version that I just loading it from a different version. We're okay now. Yeah, okay. Continuing. For Bernoulli's equation, the pressure differential between inflowing and outflowing ether, at least for the Earth, by this calculation ends up being about 2 times 10 to the minus 16 newtons per meter squared, or 2 times 10 to the minus 21 bar. Roughly, that's 1/millionth of the atmospheric pressure of the moon. You can see here, I took this out of I guess off the internet. This has the surface pressure for the various planets, including the moon. So with an 11 kilometer per second inward pressure, the ether pressure would be about 1,000,000 times smaller than we experience, and that would be what's at the moon or at Mercury. If I use a light speed as the radial speed of ether, I'm not saying that's what it is, and it's not Duncan's theory, but just for calculations, this pressure differential rises to 5 times 10 to the minus 17 bar, still below the moon's atmospheric pressure, but a lot closer. Now remember, I had a 10 order of magnitude range for the interstellar medium density, and I used the geometric mean. If I go to the maximum estimate for the interstellar medium density, which is 1,000,000 per cubic centimeter, then my calculation, I end up getting the inward pressure of ether to be 2 times 10 to the minus 16 bar if I use the Shaw ether speed of 11 kilometers per second. And it goes all the way up to 5 times 10 to the minus 12 bar if I use my light speed ether. So these are at least comparable to the lowest atmospheric pressures within our system. Still, the differential pressure is minuscule, but apparently positive enough to produce the attractive gravitational force. So again, the goal here was to show that under his theory, there would be a net pressure inward. And here I'm just trying to get some idea of the magnitudes of that and how it would compare to actual atmospheric pressures that are experienced. And clearly it's going to be a lot lower, and you would expect that. Now the third aspect that I was going to address is the mass aspect. Again, with the Venus and Earth analogy, how is the ether coming into 2 spherical bodies of approximately the same geometry, same size, know that one is going to have to, results in one having a greater gravity than the other. It has to be related to the mass. So let's consider two equally sized planets with different masses and densities. The more massive experiences the greater surface gravity. Again, comparing Earth to Venus. How does the inflowing ether know that, given the exact same geometry and distance, it must inflow faster for the more massive planet, generating greater pressure differential and thus greater gravity? Let's go back to that analogy of the inflowing ether as a capsule and being expelled as basically a cylinder or dissociated individual ether particles. Assume that due to greater mass, a larger ether capsule flows into the planet. Before I assumed the tetrahedron, if you remember. So now I'm going to, for comparison, let's assume that although it's the same size planet, it's got a greater mass. So let's assume the ether capsule coming in now is in the form of a body-centered, face-centered, cubic type of construct. It's got 8 ether particles. It flows into the planet, and it gets displaced. Coming outward, the 8 individual particles come out in a straight line and form a cylinder. The inflowing ether cube now has the volume of 33.5, which was twice what it was before, and it corresponds to a sphere of equivalent radius equals to 2. Before it was equivalent radius of about 1.6. And that's shown in dashed red. So here's my incoming capsule, here's my equivalent sphere. The volume of 8 expelled ether particles assumed to correspond to a cylinder of equivalent length turns out to be 10.667, which was twice what it was before, proceeding outward in a straight line with an average distance being half the length, 5.33. So again, whereas before I compared 2.7 to 1.6, 2.7 going out, 1.6 going in, now I'm going to look at 5.3 versus 2. So radially, this corresponds to expelled particles traveling at 2.7 times the speed of the inflowing capsule, and that's 1.6 times higher than it was before. So because of the greater mass, the rate of expulsion is higher for two of the same size spheres, but the one that has greater mass is going to see a more rapid expulsion. From Bernoulli's equation with the previous assumed values, the pressure differential between the inflowing and outflowing ether, at least for the Earth, now becomes, again I'm using the 11 kilometers per second, outward, and there's the calculation. It's 5.6, 6 times 10 to the 20 minus 21 bar. Before it was like about 2 times 10 to the minus 21. So I do the same calculations as before. I look at the light speed versus the 11 kilometers per second as the radial speed inward, and then I use the maximum possible interstellar medium density, and the differential pressure goes all the way up to a millionth of a bar, and that's comparable to Pluto's outer atmospheric pressure. So before I got my maximum, for my best case, maximum was 10 to the minus 12, and I was down here, above about 1,000 times higher than Mercury or the Moon. Now I'm at 10 to the minus 6, which puts me around Pluto. Pluto definitely has an atmosphere. So again, the numerical results really do not matter, except for the fact that the heavier planet does expel the ether more rapidly. The key is that, via another mathematical construct, Shaw's ether concept of gravity remains plausible, now accounting for the third effect, the dependence of ether inflow speed and pressure differential between the inflow and outflow, and therefore gravity on the mass. So in summary, while I can't draw a definitive conclusion regarding the ether concept of gravity, whether it's right or wrong, mathematical constructs can be developed for 3 of the key aspects. These 3 key aspects show that for these 3 aspects, the theory is certainly plausible, which was the only goal I attempted here. Further investigation into the actual physics would hopefully lead to greater insight into the potential validity of this theory. And I want to acknowledge I worked personally with Duncan throughout the development of this paper, and I thank him very much for his support. He doesn't necessarily agree with any of my speculations, which are offered only as one out of what may be many possible and different mathematical models that you could apply to Shaw's theory. And as you see, genius is more often found in a cracked pot than the whole one, and we've all been called crackpots. Thank you.
All right, questions?
I have a question. Have you done, you are doing inflow and outflow, right?
Yeah, so look at the pressure differential caused by inflow and outflow.
What have you ever done just inflow or just like a gravitonic model sort of, or what other mechanisms have you investigated for gravity?
The next paper is going to be gravity purely as a pushing force in the Lesage and Fatio theory, and with the shadowing. That'll be the next paper.
Okay, okay.
Cameron?
Yeah. Okay, in empty shell, spherical shell with homogeneous material. Inside the shell, we have a ball, or what kind of ball, but any mass anyway. But if they both are far away enough from the influence for any other object, that object inside the shell shows no gravity influence between this ball and the shell. How can we explain this phenomena with this inflow-outflow theory?
I guess I'm not... Are you talking about something at a tremendous distance away from a planet? And the fact that there's no gravitational force when you go far away from the planet?
Okay.
Or are you talking about gravity within a planet?
Okay. Usually, if two objects exist in a space, you would have gravitational influence detected between the two objects.
Right.
But now, place a ball, a solid ball or any material, inside a spherical shell, empty shell.
Empty. Okay.
And that wall of the shell is homogeneous material.
Well, you talk about something like Gauss, like inside of a Gaussian sphere, there's no, all the surface resides, everything resides on the surface of the sphere, all the charge, there's no charge on the inside?
No charge involved at all.
Yeah, like in the analogy.
Yeah,
You're saying that if you have a hollow shell, you put something inside, there's no gravity inside the shell.
No gravity between the shell and the ball.
Is that true? Because if you put not that anybody's ever measured gravity inside a sphere, but inside a solid sphere, the calculations show the gravity goes from zero at the center linearly out to the surface. So would it be the same in a hollow sphere? I don't know if I've seen the calculation of gravity inside a hollow sphere. I've seen a calculation of gravity inside a solid sphere, which I assume is still speculation because no one's actually gone into the Earth deep enough to really measure anything. There were some Greenland studies done years ago, but they only went down about 2,000 meters when the Earth's radius is 6,400 kilometers. So
that was ice cap only.
yeah, and any irregularities in the crustal areas would overwhelm any. I mean, you've got to go down at least 10% into the Earth. You'd have to go down at least 600 kilometers to see if there is a gravitational trend. Again, the calculus says that the gravity should decrease linearly from the surface down to zero as you go inside a solid sphere. But again, that's calculus. I don't know if that's true because I don't think anybody's ever really gone in there. Newton's model basically treats everything outside the sphere. He didn't get inside the sphere or do the calc. And I guess the calc is done by looking at the shells and doing integration and stuff like that. So I don't know what the answer is for a hollow sphere. For a solid sphere, supposedly it's linearly decreasing, and if you went to the center of the Earth, there'd be no gravity.
The other way to say this is that if you put the solid ball in the east, inside the hollow shell, in the east, or in the west, or in the middle, there's no gravitational difference in any of the, although in the east, it may, the solid ball may be very close to the wall or the hollow shell, but gravitational is not there, it cannot be detected.
Well, I think, again, for the solid, I think the gravity, again, the calculations show the gravity rises linearly from the center. So I guess that's, I don't know what it is for hollow, but for, again, that's the calculations that have shown, and you can find that all over the internet. But again, it's probably theory. I mean,
Okay.
nobody's actually going inside the Earth deep enough to really measure it.
You don't have to go inside the Earth, but if you, I'm sure that when you have time to sit down to calculate, I'm sure you can get to that conclusion. And between the wall of the hollow shell and the solid ball, there's no gravitational influence.
Well, again, there's an analogy to like a charged hollow sphere where all the charge all resides on the surface, and supposedly there's no electric field or anything inside. So, I mean, that is gravity analogous to that? I don't know.
Or how about this? Assume there is gravitational influence between the solid ball and the hollow shell. How that gravitational influence can be explained with the theory here?
I don't know. I mean, again, I'll let Duncan take a shot at that if he wishes, but I don't know how to, I'm not sure how to handle the hollow. Again, if it's solid, I mean, it's just the case they're just how deeply they penetrate. There's probably less penetration as the farther you go in, so there's going to be less differential effect, and that would be less gravity as you're going inward. With a hollow shell, I mean, either everything, once you get, I guess with a hollow shell, you'd say the only thing that resists the ether flowing in would be the shell itself. Once the ether got past the shell, there'd be no reason for it to have any variation from speed or whatever once it gets inside. So maybe in that case, because everything inside the shell is going at the same velocity and it's the same ether density, maybe that's why there's no gravity. It's for shells, it may be purely a surface phenomenon, whereas for solid spheres, it's a continuous phenomenon as you go inward. I guess that would be my guess as to how this might work with the model.
Any other questions?
Yeah, yes.
Okay,
Oh, yeah,
Let's get a microphone for him. Somebody help him out, please.
Yeah, I'm not sure how you explain the equivalence principle. Like how? Oops.
It's on. You got to put it close to your mouth.
Yeah.
There you go. Thank you.
Okay, I'm not sure how you explain the equivalence principle. Why would a large balloon fall at the same rate as a gold sphere? It would be exposed, the balloon would be exposed to much more ether, whereas the...
Well, again, you've got that was the idea with the different masses. The size of the capsule that's impinging is not solely based on the geometry. It's also based on the density of the material that's being impinged. So like I didn't do a comparison between two different sized spheres with two different densities. What I did is, this is my first sphere, and it has the same size as my second sphere, but their densities are different. So again, I'm looking for a mathematical construct analogous to what Duncan's theory says. So the construct I was able to come up with was, in this case, with the less dense sphere, the impinging capsule only consisted of 4 ether particles, whatever you want to call them, in the tetrahedral form. So 4 go in, 4 go out. And the equivalent radius gives me a ratio between in and out of about, what was I get? I got 1.7. Then when again, keeping it the same size, I had a ratio of 5.3 to 2, and the ratio of the speeds was 2.7, so it was 1.6 times higher. So now if I were to say, if I take this one, which is denser, and I make it bigger, versus the first one, which is less dense but is smaller, then there's probably some point at which, I guess you could do the calcs to see where it'd be equal. A bigger, less dense object would end up with the same gravity as a smaller, denser object, maybe at some point.
Okay. So is it the electrons and protons are basically what's being accelerated here. And is there any difference between the electrons and protons? Or
The acceleration here is on whatever an ether particle is. It's not protons and electrons being accelerated here. It's an etheron. I think that was the term that Stephen Rodok used, an etheron, which is basically, it's an ether particle, which I don't know if it's really a particle, or I don't know how, that's how people describe it. You think of these little spherical things going all over the place. They may not have anything to do with it. Bruce thinks that the ether is a lattice. And so it may not even be particles.
You're saying it's like Einstein's curved space. It's the space that's moving and not the protons and electrons.
There's an analogy to that. I don't think I think space is not an entity. I don't believe Einstein's space-time or any of that stuff. The ether is moving through. It's moving through space. It may be. Now, Musa has often speculated that the electric field is the ether, and the electric field that pervades the universe is analogous to an ether. So it could be something like that. Is we have the entire universe has an electric field in it, and that is the ether, and that's how things behave that way. Again, I'm on, as Dave mentioned, I'm on the fence. I don't know if there's an ether or not. I've done analyses assuming no ether, assuming ether. I don't hold to necessarily to a constant speed of light, though I do think that if there is a constant speed of light, it strongly implies some sort of medium. But I'm not sure there is a constant speed of light. So, but again, my only goal here was to take what Duncan did and see if the math fits it in 3 of its aspects. The physics of that, I really am not tackling.
Okay. Any other questions?
It's nice to dump the model off on other people. That's why I never come up with my own model. I have nothing to defend.
Okay, well, thank you very much.